In this simulation, we will determine the vector velocity and the speed. We have a particle moving on a curvilinear trajectory. At the instant t, the particle is at A, and at the instant t plus delta t, the particle is at B. In a fixed Cartesian coordinate system, the positions of A and B are identified by the vector's position. OA equals R1 and OB equals R2. And the vector displacement delta R is R2 minus R1. Its length is AB, and the traveled distance is on the trajectory on the arc AB, and its length is delta S. The traveled distance is delta S. We observe that we have a difference between the magnitude of delta R and the length of the arc AB, delta S. The average velocity is a vector. The vector average velocity is equal to the vector delta R, the displacement, divided by delta t, the duration of the motion. The average speed is a scalar quantity. It equals V equals delta S over delta t. If B is very close to A, when delta t tends to 0, the chord AB will merge the AB arc. Then the magnitude of delta R, is equal to delta S, and the chord, the arc, and the tangent at A have the same direction. We will see that by this observation. We have here the tangent to the trajectory at B and the direction AB. When B is very close to A, we see that these two lines are the same. Then, I repeat, the chord, the arc, and the tangent have the same direction, that of the tangent at A. Okay. Now, at the limit, when delta t tends to 0, the length delta r of the chord tends to delta s, then dr equals ds, and the vector dr equals the magnitude ds times ut. Ut is the unit vector tangent to the trajectory at the position of the mobile. What about the vector velocity? The instantaneous vector velocity is the limit of the average vector velocity when delta t tends to 0. The instantaneous velocity v equals the limit of delta r over delta t when delta t tends to 0. It equals dr over dt, the derivative of r. It equals ds over dt ut. The magnitude of the instantaneous vector velocity, the magnitude of the instantaneous velocity is the limit of the average speed when delta t tends to 0, and its direction is ut, the vector ut, the tangent. Okay. Now we have the relation between and the differences between the average velocity and the instantaneous velocity, the average speed and the instantaneous speed, which is the magnitude of the vector or the instantaneous velocity. Now we will speak about this coordinate system. ut and un are unit vectors at the position of the particle. It moves with the particle. This coordinate system will be very useful for the study of acceleration. We will see this in another simulation. Thank you.